In this video, we'll talk about the first step to ground fault identification, understanding what your ATevo battery charger will display when it detects a ground fault alarm. The next video in this series will show you the second step, isolating the charger from the DC bus. When the charger doesn't see a ground fault, nor any other conditions that could cause an alarm, you should see all of the following. Number 1. There will be no alarm LEDs and no common alarm visible. Number 2. The ground meter screen, which can be accessed by pressing display mode and then navigating to ground meter, or by just pressing the right or left arrow button until the ground meter screen appears, should show approximately 1/2 of the float voltage between the positive side of the DC bus to ground and half of the float voltage between the negative side of the DC bus to ground. In this case, the float voltage, 53.3 volts, is split nearly equally on both sides. When there is a ground fault, you will see the following. Number 1. A positive or negative ground fault alarm LED. This already helps us by narrowing down which side of the bus the ground fault can be found. Number 2, the common alarm LED will also likely be lit because ground faults activate the common alarm by default. Number 3, you will see one or more ground fault alarms listed among the active alarms when you press the alarms button. Number 4, you may see both ground fault warning and ground fault critical, depending on the impedance value of the ground fault detected. Notice from the ground alarm screen the impedance values that are set for each of these alarms. You may customize these values if desired. Number 5. Ground fault alarms can also trigger low priority and high priority alarms. The ground meter screen will now show something we didn't see before, an impedance value for the ground fault that has been detected. The lower the impedance value, the stronger the ground fault is. Number 7. When there was no ground fault, both sides of the bus were balanced on the ground meter screen. Now, with a ground fault, we see an imbalance between the voltage on each side of the bus, visible by the unequal voltages on each side and by the calculated value of the imbalance that's displayed in the center of the screen. This information makes it even clearer where we should look for the ground fault and how strong of a fault it is. We've just covered the first step to ground fault identification. We now understand what the ATevo charger shows us if there is a ground fault and how we can use that information. There is a simple but very effective second step to ground fault identification, isolating the charger from the DC bus. That will be covered in our next video in the series. We encourage you to watch that as well. If after watching these videos you have questions or feedback, please reach out to HindlePower's technical service team for assistance using this information or the contact form on our website. We would love to hear from you. Have a great day.